This video introduces some of the highlights of Islamic astronomy during the Golden Age of Islam. The learning goal of this video is to understand that during the Golden Ages of Islam, astronomers in the Middle East made many advances to astronomy. There is a tendency to overgeneralize cultures when regarding them historically. The contributions during the Golden Age of Islam came from variations of Islam, Persians, Arabs, Africans, and Europeans. Extensive trade routes fostered scientific exchanges with India and Asia as well. From about 700 to 825, there was a period of assimilation in the Middle East, Greek, and India astronomy. The first astronomical texts that were translated into Arabic were of Indian and Persian origin. The most notable of the texts was the Ch03, an 8th century Indian astronomical work that was translated by Muhammad ibn Ibrahim al-Fazari and Yaqub ibn Tariq after 770 CE with the assistance of Indian astronomers who visited the court of Caliph al-Mansur in 770. Another text translated was the Zij al-Shah, a collection of astronomical tables based on Indian parameters compiled in Sassanid Persia over 2 centuries. Fragments of the text during this period indicate that Arabs adopted the sine function inherited from India in place of the chords of arc used in Greek geometry and trigonometry. In 830, the Caliph al-Ma'mum founded Bayt al-Hikman, the House of Wisdom, as a central gathering place for scholars to translate texts from Greek and Persian into Arabic. These texts formed the basis of scientific knowledge. Al-Khwarizmi developed the first tables of trigonometric functions, which remained the standard reference well into the modern era. His name in the West became algorithm, and this is, in fact, the origin of the term algorithm. Al-Khwarizmi's calculations were good to 5 places, allowing for unprecedented precision in astronomy and other sciences. In Antioch, Muhammad al-Battani began with Ptolemy's works and recalculated the precession of the equinoxes and produced new, more precise astronomical tables. According to Wiki, the creation of the first observatory in the Islamic world was ordered by Caliph al-Ma'mun in 828. The construction was directed by scholars from the House of Wisdom, senior astronomer Yahya ibn al-Mansur and the younger Sanab ibn Ali al-Yahudi. It was located in al-Shamashiyah and was called Mumtaha Observatory. After the first round of observations, the sun, moon, and the planets, a second observatory on Mount Kassion near Damascus was constructed. The results of this endeavor were compiled in a work known as Al-Zij al-Mumtahan, which translates the verified tables. In 850, Al-Farghani wrote Kitab Fij Jawani, meaning a compendium of the sciences of the stars. The book primarily gave a summary of the Ptolemaic cosmology. However, it also corrected Ptolemy based on findings of earlier Arab astronomers. Al-Farghani gave revised values for the obliquity of the ecliptic and the precessional movement of the apogees of the sun and the moon and the circumference of the earth. The book was widely circulated through the Muslim world and even translated into Latin. Around 964 AD, the Persian astronomer Abd al-Rahman al-Sufi, writing in his book of fixed stars, described a nebulous spot in the Andromeda constellation. This is the first definitive reference to what we now know is the Andromeda Galaxy, the nearest spiral galaxy to our galaxy. Nasir al-Din al-Tusi invented a geometrical technique called the Tusi couple, which generates linear motion from the sun of two circular motions to replace Ptolemy's problematic equant. The Tusi couple was later employed in Ibn al-Shatir's geocentric model. Al-Sufi, from 903 to 986, made several observations on the obliquity of the ecliptic and the motion of the sun, or the length of the solar year. He also made observations and descriptions of the stars, setting out his results constellation by constellation and discussing the star positions, their magnitudes, and their color, and for each constellation providing two drawings from the outside of the celestial globe and from the inside. Al-Sufi also wrote on the astrolabe and its 1,000 or so uses. Al-Biruni, from 973 to 1050, claimed that the Earth rotated on its own axis. He calculated the Earth's circumference and fixed scientifically the direction of Mecca from any point on the globe. Al-Biruni wrote in total 150 works, including 35 treatises on pure astronomy, of which only 6 have survived. Al-Hazan advanced theoretical physics, mechanics and optics, and mathematics. Al-Hazan offered an explanation on the moon illusion, an illusion that played an important role in scientific tradition of medieval Europe. Some regard him as the founder of experimental psychology. Al-Hazan advocated that astronomical hypotheses were accountable to the laws of physics and could be criticized and improved upon in those terms. Drawn by Al-Idrisi in 1154, this is one of the most advanced ancient world maps, showing modern consolidation and created from the 70 double-page spreads of the original atlas. This celestial globe was found in Iran, or made in Iran, in 1144. It's shown in the Louvre Museum. This globe is the third oldest surviving globe like it in the world. Al-Hazan advanced sundials by writing on the construction of hour lines on cylindrical, conical, and other surfaces, and is credited with introducing equal hours, at least for astronomical purposes. Ibn al-Shatir during this time, the most notable to the advancement of planetary motion was done by this man. His most important astronomical treatise was The Final Quest Concerning Rectification of Principles. He drastically reformed the Ptolemaic models of the sun, moon, and planets, eliminating the eccentric and equant by introducing extra epicycles. Geometric, he had eliminated the Ptolemaic eccentrics, but the mathematical details of his system were identical to what Copernicus later used in De Revolutionibus, where he put the sun at the center of the solar system. There were advances in algebra and trigonometry, physical sciences, and even psychology. Many observatories were built and accurate records were made. Improvements were made to sextants. In 1500 AD, Istanbul Observatory has many instruments that are similar to the ones being used at Renaissance Europe at the same time. The philosophy of Aristotle blended with medieval theology in the great synthesis of Christianity and reason, undertaken by the philosopher-theologians such as Thomas Aquinas. The prime mover of Aristotle's universe became the God of Christian theology. The outermost sphere of the prime mover became identified with the Christian heaven, and the position of the earth at the center of it all was understood in terms of the concern that the Christian God had for the affairs of mankind.